Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, the agenda behind the video which we will be covering in today's class, around 6 to 7 number of problems has been taken or would be taken based on the concept of the continuity as well as differentiability. Once we are done with this video, from tomorrow onwards definitely we are going to start a new as well as the important topic. So let me know regarding the quality of video as well as audio, is it perfect or not? If it is perfect, just write perfect over the live chat. So at least I'll have the fair idea that the quality of video as well as audio which are transmitted from my side has been ultra clear. Probably each and everything is fine. So as we have been taking around 6 to 7 number of problems in each day, in yesterday's class also we have taken around 5 to 6 number of problems which were based on the concept of the continuity as well as differentiability, and probably day before yesterday also we took session there I took around 5 number of numerical problem based on the concept of limit, continuity as well as differentiability. So probably today would be the last class on the same sequence. In today's class I would be completing the concept of the continuity as well as differentiability completely. So let me focus over few of the questions. The first question had been mod of x minus of 1. We had to discuss about its continuity as well as differentiability. Discuss about its continuity as well as differentiability. About its continuity and differentiability. So you guys must be able to solve this problem within maximum 1 minute. So that frame of time of 1 minute has been allocated to all of you. Try to solve this problem and comment over the live chat what about its status of continuity, what about its status of differentiability. So 1 minute has been allocated to all of the students who have been watching this video live. What would be the appropriate answer? First you had to comment about the state of continuity, then you had to comment about the state of the differentiability of this given function. And if the function is found to be discontinuous at a certain point of x, and if the function is found to be non-differentiable at a certain point of x, you also had to mention which are the different points where the function has found to be discontinuous and has been found to be non-differentiable. Tell me what would be the best most answer for this given problem. The problem had been mod of x minus of 1. I need to discuss about its state of continuity as well as differentiability. This problem should not take more than 1 minute to get solved. Mod x minus of 1. You have to find the state of its continuity as well as the differentiability throughout the range of x, which starts from minus infinity, goes till plus infinity. Tell me what would be the best most answer. Continuous but not differentiable. Alok states the function is continuous throughout the range of x, but it's not differentiable throughout the range of x. Alok, I would ask the next question to you. May I know what are the different points of x at which the function would be found to be non-differentiable? Can you dictate the values of x at which the function would not be differentiable? Because in future, in question, they may ask this sort of questions also. The point of x where the function is found to be non-differentiable. Obviously, Alok, your answer is perfectly well. The function would be continuous throughout the range of x. The function would have few points of non-differentiability. I wanted to have those exact points. Tell me the values of x where the functions would be non-differentiable. Let me do one thing. Let me draw the mod of mod x minus 1 over a 2D plane. And once you will visualize the mod of mod x minus of 1 over the 2D plane, you yourself would be able to judge whether the function is continuous throughout the range of x or not. And similarly, what are the different points where the cusp formation has been taken place such that the function would not be differentiable at that point. For that, what I am going to do over here, I am going to take a xy plane. Let me take a xy plane. Just a minute. Let me take it till down. I am going to draw the 3 different curves understand the concept behind this problem into the more detailed way. First, focus over the mod of x. May I know how the mod of x looks like? The mod of x would be a V-shaped curve which would be symmetrical around x is equals to 0 axis or maybe y axis. So here it had been x axis, here it had been y axis, and this curve has been the curve for mod of x. And how the mod of x is being defined? For the negative value of x, it's being defined as minus of x, and similarly for the positive value of x, it's being defined as plus of x. So till this point, each and everything must be clear to all of us. The Manju states at x is equals to 1, we'll see that. Now what is happening over here? Now the mod of x has been shifted towards downside with the unit of 1. That means this cusp was formed at 0, 0. Now it would form at 0, minus 1. So obviously this complete V shape would get down. So if it is getting down, definitely the new curve would come in our hand, and the curve would be sort of this. The curve would be sort of this. May I know how would be the behavior of the curve? How would be the behavior of the curve? Few of the changes are going to take place. Anyways, there would not be any change in its slope because the same curve has been shifted towards downside. So obviously the slope is not going to change. Still it would be minus 1, still it would be plus 1. The slope of this straight line is not going to change. The slope of this straight line is not going to change. The slope would remain as it is. Only as it has been shifted towards downside with the worth of minus 1 would get associated both other side. It would become plus of x minus of 1. If you don't understand, you can understand in this way. Mod of x, how it's been defined? It has been defined as a minus of x for the negative values of x. It has been defined as a positive of x for the all positive values of x. So towards left hand side, the mod of x would be kept as a minus x minus 1, which we did so. And similarly for the positive value of x, the mod of x would be defined as a plus of x minus of 1, which we did so. Agreed? Now in next step, what we had to do? We had to take the modula of mod of x minus of 1 once again. So may I know which curve it had been? It had been mod of x minus of 1. Again, I had to take its modula. Once you will take its modula, what is the change you will be experiencing? All of the curve which have gone into the third as well as fourth quadrant would get flipped and would go towards upside. So where are the points where the changes would take place? Obviously, this is the first point. This is the second point where the changes are supposed to take place. So I am interested to find these values. May I know what are the values of x you will be having? See, this was minus x minus of 1. This is the point at which this curve is crossing through x axis or y is equals to 0 axis. That means this has to get compared with 0. When the minus of x minus of 1 would get compared with 0, may I know what is the worth of x we will be getting? The worth of x would be precisely equals to of minus 1. So obviously this point where minus x minus of 1 is crossing through the x axis had been x is equals to minus 1. Similarly, here the equation of the straight line had been x minus 1. Again, I would try to know the intersection point of a straight line over the x axis. X minus 1 has to get compared with 0. So the worth of x would be found to be plus of 1. So may I know what would be the worth of x over here? It would be plus of 1. If you go before minus of 1 and after minus of 1, the curve remains in first as well as second quadrant, and hence while taking its determinant of mod, the result would not change. The result would remain very same. Here it would be very same as earlier one. Yes. And here also it would be very same. But now in between minus 1 to 1, what is happening over here? This curve has been prevailing towards the third as well as fourth quadrant where the value of y had been negative. Once we will take its modula, what would happen? All of the negative values of y would get shifted towards upside, or it would become positive. So lump sum, the curve which you would get in your hand has been this. So if you want to bifurcate the mathematical equations, x lesser than minus 1, the curve is being defined by a straight line, and the straight line equation had been minus x minus 1. Similarly, this curve remains as it is. When we go beyond x is equals to of plus of 1, that had been x minus 1. May I know what would be the equation of a straight line over this as well as this segment? you yourself would be able to calculate it easily. The slope would be plus of 1 because earlier the slope was minus 1 and now it has been flipped taking the reference of x-axis. The slope magnitude would remain same, the sign would get changed. Earlier it was minus 1, would change to plus of 1, would change to plus of 1. So it would become plus of x, and as it is intersecting at 1 on y-axis, so simply it becomes plus of x plus of 1, plus of x plus of 1, and similarly this equation would be minus of x plus of 1, plus of 1. Could you understand what I am saying? Agreed, no? So till this point, each and everything must be clear to all of us. The student who have been new to my video, let me explain what we were discussing so far. I have taken one problem. The problem was mod of x minus of 1, and I need to discuss about its continuity as well as differentiability throughout the range of x, So many of the students find this sort of problem very difficult. So what I say, whenever you have this sort of problem or the problem related to the absolute function, try to draw over the 2D plane. For that, what I have done, I have taken an xy plane. At very beginning, I have focused over the mod of x. May you know how the mod of x looks like? Obviously, it is going to be a V-shaped curve, which would be symmetrical taking the reference of y-axis, and at x is equals to 0, the worth would be 0. Obviously, it had been like this. For the negative value of x, mod of x is being defined as minus of x, and for positive value of x, the mod of x is being defined as plus of x. Ayush Mittal, no. Ayush Mittal, if you are from either of the branch, electrical, electronics, mechanical, civil, production, instrumentation, this mathematics is going to give you good insight about the engineering mathematics. And yes, we have been discussing about the basic part of the engineering mathematics, but this sort of problem are repeatedly going to be asked in different streams. So you can't say it's just basic of mathematics, it's the basic of engineering mathematics from where the question do come repeatedly. Agreed? Till this point, each and everything must be clear to all of us. Now, what is happening over here? The mod of x had been as it is, but now has to get shifted by 1 towards vertically down. So initially it was making a cusp at 0, 0. Now it would make a cusp at 0, 1. Why 0? Because the y-axis had the value of x as 0. So obviously the cusp has been formed at 0, 1. Now what we are going to do in the next curve, now I am going to take its modulo also. I am going to take the modulus of this function. What does it mean by the modulus of this function? As far as the mod of x minus of 1 is concerned, the part of mod of x minus of 1 were in third as well as fourth quadrant. You must be knowing about it. In third as well as fourth quadrant, the value of y used to be negative. But once I am taking the modulo of this complete function, once we take the modulo, the result would always be positive. Yes. Mechanical, definitely I use. We are covering each and everything related to the mechanical. So what would happen? See, if you take the reference where the x is lesser than minus 1, the curve had been in second quadrant, definitely there would not be any change. Similarly, if I'll take the reference where the x has been greater than 1, again the curve had been in first quadrant, there would not be any change. But in between minus 1 to 1, what had happened? The curve had been in third as well as fourth quadrant where the value of y had been negative. So what we are going to do over here, we are going to flip this curve towards upside while taking its modula. If I take its modula, if the worth is minus 1, it would go to the plus 1. If the worth is minus 2, it would go to the plus 2. Put together, the complete curve would get shifted towards upside. So as far as this curve is concerned, no, mod of x minus of 1, this can be bifurcated into the 4 different parts. First, I can take the reference of minus 1. Second, I can take the reference of plus 1. So how the curve would look like? You can see very well. When the curve had the x lesser than minus 1, how the nature of the curve had been? The slope had been minus 1. And similarly, it has been crossing through the y-axis at y is equals to of minus 1. Similarly, if you will take the span where the x had been in between minus 1 to 0, in between minus 1 to 0. I do not have much space over here. How the curve is being defined? The curve has been defined as a plus of x plus of 1. Similarly, if you take the region between 0 to plus of 1, how the curve is being defined? The curve has been defined as a minus x plus of 1. And similarly, once you go beyond x is equals to 1, what is happening over here? The curve has been defined as x minus of 1. That means this curve had the 4 different behaviors in the different spans of x. different spans of x. Anyways, if you don't go, mathematical relationship is still, you must be able to conclude which are the different points of x where the function would be non-differentiable. You can see very well the curves were formed at x is equals to of minus of 1 as well as at x is equals to of plus of 1. Not only that, even at x is equals to of 0 also. X is equals to 0 also. So as far as this function is concerned, it would be continuous in all possible real values of x, no doubt. And similarly, the function would not be differentiable at the point where the cusp formation has been taken place, and they are at x is equals to of minus 1, 0 and plus 1. Minus 1, 0 and plus 1. So what would be the bestmost answer? The function would remain continuous throughout the span of x, whereas the function would remain differentiable throughout the span of x except x is equals to minus 1, 0 and plus 1. Minus 1, 0 and plus 1. Even mathematically you could have checked by yourself. See what is happening over here. X less than equals to minus 1, the curve has been defined as a x minus of 1, and similarly in between minus 1 to 0 the curve has been defined as a plus of x plus of 1. So if you will take the differentiation precisely at x is equals to of minus 1, with the help of first function the slope had been minus 1, whereas with the second function the slope had been plus 1, and you yourself would be visualize it easily. If you take the LHD taking the reference of minus of 1, the slope had been negative and the worth had been 1. Similarly, if you go beyond x is equals to of minus 1, the RHD states the slope had been plus 1. Slope had been plus 1, which we have calculated over there. And similarly, if you take the differentiability test at x is equals to 0, towards LHD the slope had been plus of 1, and towards the RHD the slope had been minus of 1. You yourself would be able to check from here, minus of 1. So again, the left hand derivative as well as right hand derivative has not been same, and if they have not been same, obviously the formation of the curve would take place. And same goes with this, the slope is going to get plus 1, plus 1. So here, so you can see very well, the slope was suddenly switched from minus 1 to plus 1. There would be a formation of curve. The function would not be differentiable because you cannot draw a unique tangent at x is equals to of minus 1. Similarly, the same case has happened over here. The slope was suddenly changed from plus 1 to minus 1. Again, the curve would be formed. Wherever the slope is changed suddenly, keep in mind there curve would be formed. So again, here the curve has been formed and the function is found to be non-differentiable, and the same process goes over here. Could you understand? Could you understand? I would like to ask from each one of you, could you really understood what exactly I wanted to communicate through this problem? The problem was mod of x minus of 1. I was discussing about its continuity as well as differentiability. The function would be continuous throughout the range of x, whereas the function would be non-differentiable in few discrete points, which are x is equals to minus 1, comma 0, comma 1, comma 1. In the same sequence, let me go ahead with the next question. The problem had been, it had been the second problem of the day. Again discuss about the continuity as well as the differentiability of an absolute function. Earlier it was mod of x minus of 1, now it has been changed to the mod of x square minus of 1. Discuss about its continuity as well as differentiability. You can expect this sort of problem in GATE examination because they are not very heavy problem, usually which is being asked in IIT JEE and all. It has been a light question if you have a little bit idea about the parabolic function. If you have a little bit idea about the absolute function or modulus function, definitely you would be able to crack this problem out. You would be able to crack this problem out. The problem had been modulus of x square minus of 1. I had to discuss about its continuity as well as the behavior of its differentiability. Continuity as well as the behavior of its differentiability. The same approach I would be using once again, and that had been graphical approach. At very beginning, I would be focusing over the x square, which would be upper facing parabola. X square minus 1, as we had earlier, the complete upper facing parabola would be shifted by 1 unit downside, and then we would take its modula. Once we take its modula, all of the curve which had been there towards the third as well as fourth quadrant, the worth of the y had been negative, would be flipped towards upside, and now end of the day, whatever the result you have in front of you, that would be the final curve for the given mod of x square minus of 1. Mod of x square minus of 1. Could you understand what I am saying? So let me solve this problem graphically. I have taken a xy plane, here goes the y axis and here goes the x axis. I would try to solve this problem step by step. So at very beginning, I would be focusing over x square, then I would be focusing over x square minus of 1, and then at the end I would be focusing over mod of x square minus of 1. Mod of x square minus of 1. So let me focus over the x square first. How the x square would look like? Obviously, it is a upper facing parabola. Upper facing parabola which is crossing through origin. So this had been y is equals to of x square. Now let me focus over the x square minus of 1. What would happen? The same upper facing parabola would be shifted by 1 unit downside. So how the curve would look like? The curve would look something like this. This curve had been x square minus of 1. X square minus of 1. Till this point, each and everything must be clear to all of us. Now what is happening hereafter? Just a minute, let me shift a bit because it is not looking very symmetrical. Sort of this, yes. Sort of this. Now, once we'll take its modula, may I know what are the different zones where the effect would be pursued and what are the different zones of x where there would not be any effect. If you go before the value of x, there would not be any change of this curve because this curve is already had the value of y as positive because it was in second quadrant. And if you will go beyond x is equals to of this critical point, again this curve is not going to change. Why? Because the value of y had been positive over here. So only this is the reason where the complete curve would get flipped taking the reference of x-axis. So now again these 2 points are going to be very critical point to analyze, this as well as this. How will you know about the value of x? These are the value of x at which x square minus of 1 crosses through y is equals to 0 axis. Because the x-axis is being defined as y is equals to 0 axis. When we were discussing about the basic methodology of the engineering mathematics, there I discussed about this thing in the great detail. So what we do, I would be comparing x square minus of 1 with 0. May I know what are the possible values of real values of x where the x square minus of 1 would become 0? Obviously, the points are being x is equals to of plus 1 or minus 1. So here this intersection point would be at x is equals to of plus of 1 and this intersection point would be at x is equals to of minus of 1. So you can say when the x is lesser than minus 1, there would not be any change, the curve would remain as it is. Similarly, if the x is greater than plus of 1, there would not be any change, the curve would remain as it is. But in between minus 1 to 1, this complete curve would get flipped taking the reference of x-axis, multiplication of x would take place. So how the curve would look like? So precise curve would look something like this. So as far as this modulus function x square minus of 1 is being concerned, we had to distribute into the 3 different zones of x. When the x is lesser than minus 1, you yourself would be able to see there has not been any change as far as the x square minus of 1 is concerned and as well as this curve is being concerned. So obviously it would remain as x square minus of 1. Similarly, if you come in between the range of minus 1 to plus 1, the curve has been flipped taking the reference of x-axis. That means the x square minus of 1 got multiplied with a minus sign. Hence, the result would be minus of x square plus of 1. Yes. Similarly, if you will take the reference of x greater than plus 1, may I know how the curve had been? The curve had been very same as x square minus of 1. And if we'll be talking about the continuity, obviously the function had been continuous throughout the range of x because there has not been any discontinuous point throughout the range. That's the first thing. If we would be discussing about the point of non-differentiability, obviously x is equals to of minus of 1 and x is equals to of plus of 1 are the point at which the function had been found to be non-differentiable because there had been the formation of the cusp. There had been the formation of cusp. If you don't able to understand this, you can do it by mathematical calculation. See, if you take LHD, or you can say the differentiation of the function at x is equals to of minus 1 minus dy by dx at x is equals to of minus 1 plus. Anyways, if you will be discussing about the differentiation of the function at minus 1 minus, so obviously you have to differentiate this function. Once you will differentiate it, the result would be 2 times of x. 2 times of x. Now the 2 times of x has to get multiplied with the minus 1. The result would be minus 2. You yourself would be able to see almost here the slope is minus of 2. Similarly, if you find the right hand derivative, which function has to be chosen? Obviously the function which has to be chosen has to be minus of x square plus of 1. Once you will differentiate it, the result would be minus of 2 where the x has to be fed as a minus of 1, minus 2 into minus of 1 would result the result as plus of 2, would result as the plus of 2. So one thing had been quite sure, if you will be discussing about the slope at this point, the slope had been minus of 2, slope at this point the slope has been plus of 2. That means there had been a sudden change in slope around x is equals to of minus of 1. Obviously the function won't be differentiable. The same case goes over here. If you will calculate the slope over here, you yourself would be able to understand as the value of x is increasing, the value of y had been decreasing, the slope would be negative. Once you will calculate its slope from here, the slope would be what? Minus of 2, and here the slope would be plus of 2. So may I know what are the different points at which the function would be non-differentiable? The point would be x is equals to of minus of 1 and x is equals to of plus of 1. These are the 2 points at which the function would be non-differentiable. These are the 2 points where the function would be non-differentiable. So till this point, each and everything must be clear to all of us. In the same sequence, I have designed the next question, which would be the third question of the day. Let's take the function f of x is being defined as x square for x less than equals to of 2 and has been defined as a straight line. May I know what used to be the standard form of the straight line? Let's take mx plus ax plus b or mx plus c, whatever is choice is yours. For x greater than equals to of or greater than of 2. Find the equation of the straight line. Straight line for which function f of x is differentiable throughout the all positive value of or all real values of x. I would like to have the input from each one of you. What would be the best most answer for this given problem? I need to find the equation of the straight line for which the function f of x would remain differentiable throughout the range of x, which starts from minus infinity till plus infinity. You must be able to solve this problem maximum to maximum within 90 seconds. Tell me what would be the best most answer. Deliberately I have designed this problem with certain different angle because this sort of problem has not been appeared so far in GATE examination. Should I be repeating this problem once again? The f of x has been defined as a x square when the x was less than equals to of 2 and has been defined by a straight line for x greater than 2. I need to find the equation of the straight line for which the f of x remains the differentiable function throughout the range of x. throughout the range of x. I want the input from each one of you. Maximum to maximum you can take 90 to 100 seconds. So I would wait for the response from each one of you. What would be the equation of that straight line? What would be the equation of that straight line? I want the input from each one of you. I want the input from each one of you. The fx is being defined as x square, where the x is being defined for the lesser than equals to of 2, and similarly it has been defined as a straight line for x greater than 2. I want the equation of the straight line such that the function f of x would remain differentiable throughout the range of real values of x. Tell me what would be the best most answer? What would be the best most answer? I want the input from each one of you. What would be the best most answer? Tell me what would be the best most answer for this given problem. Let me start processing this problem. For the better understanding of this problem, let me analyze this problem over the graphical domain. See what is happening over here. You had the two distinct functions. The first function was a upper facing parabola which is being crossed through the origin, because the y had been x square, so once you will keep x is equals to 0, definitely y would become 0. So it had been a upper facing parabola, and this function was defined till x is equals to of 2, including x is equals to 2, including x is equals to 2. Y is equals to of x square. At x is equals to 2, may I know what would be the worth of x square? That would be 4. That would be 4. So obviously the worth would be 4. So you can say the abscissa of this point would be 2 and the ordinate would be 4. Till this point each and everything must be clear to all of us. Now from here onwards we had to design a straight line in such a way that it must be differentiable precisely at x is equals to 2. I need not to bother about the x square except x is equals to of 2, and similarly I need not to bother about the differentiability of the straight line apart from x is equals to 2. Why? Because y is equals to x square remains a continuous as well as differentiable function throughout the range of x as it has been a polynomial. Similarly, y is equals to of mx plus c, it used to be a first degree linear equation, would be continuous throughout the range of the value of x. Only and only the point at which the differentiability or the continuity can get lost, and that had been the point of change. May I know what had been the point of change? The point of change had been at x is equals to 2. At x is equals to 2. So what you had to do? You had to design a straight line such, what I am saying, you had to design a straight line such that that straight line must be passing through 2, 4. That's the first story. What I am saying, that straight line must be passing through 2, 4. Yes sir, we can design that. We can design that. But what I am saying, if the straight line is passing through the 2, 4, whether it's more than adequate to have the differentiability at x is equals to 2? No. That straight line should also be tangent over 2 minus. That straight line should also be tangent at 2 minus. So obviously this equation of straight line, this equation of straight line, this equation of straight line would be ruled out, and you had to just take the reference of the last straight line. So how we would solve this problem? First, the function is found to be differentiable at x is equals to 2, has to be continuous at x is equals to 2. So for the time being, the equation of the straight line has been taken as mx plus c. Mx plus c at x is equals to of 2 has to be very same as x square at 2, which has been 4. So from here the conclusion which we are getting, it had been 2m plus of c is equals to a 4. That had been the first conclusion. You can write this as a first equation. Agreed? In the same sequence, what we are saying, the slope of the straight line has to have the same slope which a parabolic curve had at x is equals to of minus of 2. May I know what about the slope of this straight line? You had to take the first differentiation of mx plus of c, which would lead the result as m. which would read the result as m, and has to be very same as the differentiation of x square around x is equals to of 2 minus. X is equals to of 2 minus. So from here, the result what we are supposed to get, if you will take the differentiation of x square, the result would be 2 into of x, and the x would be fed as 2. The result would be 4. The result would be 4. So once you have the m as 4, you can feed the m as 4 over here. So it becomes 8. The c becomes 4 minus of 8. The c would become minus of 4. Minus of 4. So may I know what would be the equation of the straight line? The equation of the straight line is going to be mx plus c, and that had been 4x minus of 4. 4x minus of 4. Even you could have solved this problem in a different way. The straight line is being defined as mx plus of b, mx plus of c, or maybe ax plus of b. So you could have taken, rather writing it as straight line, you could have taken this as ax plus b. And as the function has to be differentiable at x is equals to 2, definitely the function has to be continuous at x is equals to 2, and at the same time the LHD has to be very same as the RHD. So at very beginning what you would do, you would match the magnitude of both of the function at x is equals to 2 as we have done in the first step. Once we are done with that, definitely you would come across the first situation, and now what you will do, you will take its first derivative, its first derivative would be 2 of x, its first derivative would be a. You would compare at x is equals to 2. If the results are same, obviously you would be able to get the value of a as well as b, m as well as c, m as well as c. So till this point, probably each and everything must be clear to all of us. So 3 different kinds of the problem we have been visualizing so far. The first problem was mod of x minus of 1. The second kind of the problem was mod of x square minus of 1. Again, I was discussing about the concept of the differentiability at this moment of point. And the third question in the row was the function f of x was being defined as x square for the x less than equals to of 2, and as a straight line for x greater than 2. I wanted to have the equation of the straight line which would satisfy this requirement. So till this point, each and everything must be clear to all of us. And the student who may not be noting it, I would request to all of you, just try to note it down, each and individual concepts which has been taught in the class. But anyways, after end of the class, definitely I am going to share this slide on my Telegram group. So definitely I would request to all of us, follow me on my Telegram group. There I would be posting the PDF of the slides which has been prepared in each and individual pages. In the same sequence, let me move forward and let me take the next question. It has been the 4th question of the day. May I know what the question had been? The f of x had been equals to of 1 minus of cos 4x divided by of 8x square. Fx is being defined by this function when the x is not equals to 0. Whereas at x is equals to 0, the worth of the function is being defined as k. Find the value of k. The question had been find the value of k. Value of k for fx to be continuous. At x is equals to 0. I would like to have the input from each one of you. What would be the best most answer for this given problem? So this problem should not take more than maximum I am saying 1 minute. So I would wait for next 1 minute and I would wait for the reply from each one of you. Tell me what would be the best most answer. What must be the value of k for which the function f of x would remain continuous around x is equals to 0. May know how the function would remain continuous at any text point c. The worth of the function at c minus, at c plus has to be very same as the worth of the function at precisely c. What does that mean of it? That means the function should possess the limit around c, and the worth of the limit has to be very same as f of c itself. worth of the function has to be f of c itself. Tell me what would be the best most answer? What would be the best most answer? Let me start with its solution. If the function f of x has to be continuous around x is equals to 0, that means the worth of the function has to be very same as its limit. The worth of the function has to be very same as its limit. So Pranali Ingule says 1. Can I get any other answer apart from this? So first of all, if f of 0 minus has to be equals to of f of 0 plus, that means the limit should exist at that point where the continuity has to be ensured. Not only that, even the worth of the function has to be very same as f of 0. F of 0. May I know what had been the f of 0? The worth of the function precisely at x is equals to 0 had been k. That means once you will calculate the limit of this function around x is equals to 0, the limit should exist. If the limit is existing, definitely f of 0 minus would be equals to of f of 0 plus. Similarly, the worth of the limit should match with k. So you had to find its limit, whatever the result do come, that has to match with a k, and end of the day you would be getting the value of k from here. Could you understand what I am saying? Should I be repeating once again? You had a function f of x where this complex function was defined everywhere except x is equals to 0. Whereas at precisely x is equals to 0, the worth of the function is being defined by k. I wanted to have a situation at which the function f of x would be a continuous function at x is equals to 0. May I know what is the required condition to keep the f of x to be continuous at x is equals to 0? The required condition had been very same. The worth of the function just before 0, just after 0, and precisely at 0 has to be very same. Just before 0, just after 0, precisely at 0 has to be very same. May I know what had been the worth of the function at precisely at x is equals to 0? That had been key. K. F of 0 minus as well as f of 0 plus, what it had been? It had been the left hand limit as well as the right hand limit. If the limit do exist, the left hand limit as well as right hand limit would remain same, and that value has to get compared with k. So now more or less we had to find the limit of the given function. I need to find the limit of the given function that had been limit x tends to 0. 1 minus of cos of 4x divided by of 8 times of x square. You could have solved this problem with the two different methodologies. Either you could have used the concept of L'Hospital rule, or otherwise you can use the trigonometric identity. May I know how the trigonometric identity can be used over here? See, the limit x has been tending towards 0, no change. Towards denominator side, still you had 8 of x square. Now what you could have done over here, the 4 of x could have been taken as 2 times of 2 of x, where the 2 of x has been taken as absolute angle, which is getting multiplied with 2. How the cos of 2 theta is being written? It has been written as 1 minus of 2 times of sine square theta. So here the result would be 1 minus 2 times of, just a minute, 1 minus would remain as it is, no? 1 minus of 2 times of sine square of 4x. Till this point, each and everything must be clear to all of us. And here the 4 has been changed to 2 now. So once we'll open it out, definitely 1 and 1 is going to go out. Minus and minus would become plus now. So here it becomes limit x tends to 0. See, 2 divided by of 8 would be 1 upon 4. 1 upon 4, and here goes sine square of 2x divided by of x square. Sine square of 2x divided by of x square. Tell me what would be the best most answer? You had to get the limit out of this. What's the change you would be expecting? Tell me. What I would do? I would try to keep this as 2x has been raised to 2. So once you keep this as 2x has been raised to 2, definitely the 4 has to get multiplied over here. The result would be 1. And as you guys would be able to recall, the sine square of mx divided by of mx, the result was 1. What I am saying, sine of mx divided by of mx, the result was 1. And here you have got the two distinct component. The first one was You can write this, no? Limit x tends to 0. Sine of 2x divided by of 2x into limit x tends to 0. Sine of 2x divided by of 2x. Both would result as 1 getting multiplied with 1. End of the day, you would be getting the result as 1. So the worth of k has to be precisely 1. So the best most answer for this given problem has been found to be 1. In the same sequence, let me take another problem. And that would be probably the last question of the day. Again, we had a function f of x, which has been defined in two parts. The first part was 1 plus of k of x minus of root over of 1 minus of k of x divided by of x. And this part of the function is valid when x had been in between -1 till 0. And now at x is equals to 0, the nature of the function got changed. It changed to 2x plus of 1 divided by of x minus of 1. If the x had been in between 0 to 1. Find the value of k such that, the question would be, find the value of k such that, the question goes like, find the value of k such that function is differentiable at x is equals to 0. I want the input from each one of you. Tell me what would be the best most answer for this given problem. This problem should not take more than 120 seconds. Definitely, it's not a difficult problem, but comparatively complex problem, because the square roots are getting involved with the function of f of x. That is what I am saying. It is comparatively complex in nature. Tell me, what would be the worth? One thing I had been quite sure. If you wanted to keep this function as a continuous function around x is equal to 0, f of 0 minus f of 0 plus as well as the worth of the function at x is equal to 0 has to be very same. May I know what would be the worth of f of 0? The f of 0 has to be asked from the first function or the second function. It has been clearly known the worth of the function cannot be asked from the first function because it has not been defined at x is equal to 0. Whereas the second function has been precisely defined at x is equal to 0. So f of 0 has to be asked from the second function. X has to be fed as 0 plus of 1, and here it becomes 0 minus of 1. 0 minus of 1, the result what we are supposed to get had been minus of 1. Not only that, even if you are interested finding the f of 0 plus no, then also it would be minus of 1. Why? Because at x is equals to 0, the numerator as well as denominator had been a continuous function. So rather putting its limit straight away, you can feed x is equals to 0 towards the numerator as well as denominator, which would lead the result as minus 1. But now your turn is to get the worth of f of 0 minus, where the limit x would go to the 0 minus of the given function, 1 plus of kx minus root over of 1 minus of kx divided by of x. If you feed x is equals to 0, what happens? This would be knocked off, The result which would be held out is simply going to be 1 minus of 1. That would be 0 towards numerator and similarly 0 towards denominator. So with the help of L'Hospital rule, you can get the value of k. So get me the value of k. What would be the precise most answer? Get me the value of k. You will take the differentiation towards the numerator as well as denominator and you will try to get its answer. May you know what would be the differentiation towards the numerator? It would be precisely equals to of, x to the power of half. When we take its differentiation, it becomes half, where the root of x would be jump towards denominator side. In the same sequence, what's happening over here? it would be 1 upon 2 root over of 1 plus of kx, 1 plus of kx. And then we would take the differentiation of 1 plus of kx, which would result k over here, which would result the k over here. Similarly, if I take the second component and if I take its differentiation, 1 upon 2 again would be coming out. The factor which would be left out would be 1 minus of kx, and once we'll take the differentiation of 1 minus of kx, this becomes 1, it would get multiplied with k. It would get multiplied with k. The x has to be fed as 0 minus, that's simply equals to of 0, and it has to get compared with minus 1. It has to get compared with minus 1. So from here easily you can find the value of k. So when we feed x is equals to 0, definitely this becomes 0. This becomes 0, 0. Root over of 1 would become 1, root over of 1 would become 1. So the factor which has been left out had been k divided by of 2 plus of k divided by of 2 is equals to of minus 1, is equals to minus 1. K divided by 2 plus of k divided by 2 would result k, and the result has been found to be minus of 1. So the worth of k has to be precisely minus 1. The worth of the k has to be precisely minus 1. So I would do one thing. Once this class is getting over now, I would put this PDF over my Telegram group. I would put this PDF over the Telegram group, so that it would be much simpler to all of us to follow it. Agreed? So probably till this point, yes, Pranali Ingole says the k has to be equals to of minus 1. That's very perfect. That's very perfect. So this is all about the concept of the continuity as well as differentiability, which I wanted to discuss. From tomorrow onwards, we would jump into the next topic. I would like to have the suggestion from most of us, which topic I should be dealing from tomorrow onwards. If you have any kind of suggestion, you can put it over the live chat. Otherwise, according to me, I would start any of the new topic, Let me see what has been the Telegram. Just a minute. You can search by ABCD123DF. Anyways, I would try to put its link also, but otherwise you can search with ABCD123DF. I would try to put this PDF there itself. The Manju states probability, okay, but the probability requires a little bit idea about the integration and all, because once you'll go into the probability distribution as well as density, there we discuss about the area under the curve, and the area under the curve has to be calculated using the integration alone. Probability. Yamini Bharga also states the probability. Anyways, we'll see that. Because the probability has been a very, very important topic, as well as I have seen the topic where most of the students find themselves very difficult. So you can follow this Telegram group and we'll think, can we start the then integration. Okay, then we'll think which topic we had to get started with in the next class. I would request to each one of you, try to maintain the population over this group so that I would have the better enthusiasm and I would plan new things for all of you. Okay, then this is all about the today's video. We would meet with the next video with the next topic precisely at 9 PM tomorrow. Till then, bye bye, take care, good night.